Welcome to the Q&A session 5 from the playlist of gravitation. This session is based on the session number 2 in which we have studied about the gravitational field intensity. So here the question is, a solid sphere has a density of rho and a radius of capital R. So the gravitational field at a distance r, small r, from the center of the sphere when small r is less than r is. So there are 4 options here and we have to find the correct one. Now since r is small r is less than r, it means that the point is lying beneath the surface of the sphere. And in the session number 2 we have learned that the gravitational field intensity at a point inside the surface of a sphere is given by I is equal to gm into small r divided by r cube, where r is the distance of the point from the center of the sphere and this capital R is the radius of the sphere. Now here we have to find the options out of these 4. So here since from these 4 options we can see that the distance r from the center of the sphere is given in terms of the density and the radius of the sphere and the distance of that point from the center of the sphere, and here g is the gravitational constant. So here I will be using the formula that mass is equal to density into volume. Now here m is the mass of the sphere, so m will be equal to density, which is already given, and the volume of the sphere is equal to 4 by 3 pi r cube. So now this the value of this mass will be substituted in this equation, and the value of I will be g now m will be equal to into rho into 4 by 3 pi r cube and multiplied by small r divided by r cube. So from here this r cube and r cube will get cancelled out, and finally the gravitational field at the distance r from the center of the sphere will be equal to g rho into 4 pi r divided by 3. So here the correct option will be, this is the 4th one, that is 4 pi rho rg, 4 pi rho rg divided by 3. So the correct option here is D. Now here the only thing which we have to remember is that if small r is less than r, that is when the point is lying beneath the surface of the sphere, then we have to use the formula of the gravitational field intensity given by I is equal to G capital M into small r divided by r cube, where M is the mass of the sphere, r is the distance of that point from the center of the sphere, and capital R is the radius of the sphere. And thereafter we have used the formula for the mass, which is equal to density into volume. So the volume of the sphere is equal to 4 by 3 pi r cube. So by substituting the value of m as rho into 4 upon 3 pi r cube in this equation, that is I is equal to g into capital M into small r divided by r cube, we found the value of the gravitational field intensity as g into rho into 4 into pi into small r divided by 3, and the correct option was D. So thank you very much for joining this session. In the next session I will be taking up a different type of a question which will be based from the topic of gravitational potential. So till then, have a nice day. Bye.